And we're back. So, anyways, as you can tell, I was pretty passionate regarding the use of the NMC versus the so-called cloud power, cloud first solution from APC or any type of cloud services that are offered by other companies. So, using this or using the serial or the USB, that's all local within your network. And by all means, if set and configured properly, this can absolutely be viewed, seen, controlled outside of the network or on the internet. All right, but one has to assume that you've secured the network properly, or you put the proper due diligence into that access. So in my environment, I don't do that. All right, so there's obviously a compromise, meaning if I had to remotely control this device or see the metrics or what have you, I wouldn't be able to. But again, my philosophy is secure the network at all times, reduced amount of holes, penetration points, etc. So, and remember, it comes down to the basics. If you need to manage something remotely, that means there's something going on that you haven't thought about, or there's a weakness that is just there. Okay, so all the bones in my house are solid. The network, electricity, the infrastructure. It doesn't matter what it is. So this is why I don't need to worry about accessing the UPS system. Okay, if I have to, I can always turn it on remotely, and that's a one time, one off. But it's not something I have on and available every day, 24/7, open for penetration to somebody else. All right. So, anyways, as I mentioned, this card has multiple features, which is great. Okay, because I didn't want to understate, the value of this card, but I mean, for $500-600, that's a lot of cheddar. Okay, that's a lot of cash for what essentially is a overglorified network card, regardless. So this device offers two ports, and these two ports are meant for different type of I/Os, whether it be for a temperature sensor, a humidity sensor, etc., etc. Okay, so you could put a combination of the two or use one or whatever. So the intent is obviously to monitor the environment where these devices are sitting. Okay, so in my house I already have more than 72 one-wire sensors to detect the temperature, the humidity, the pressure, and so forth. So this is more as a backup, a failover, an extra measure. So I already have these things already set up. Not everyone has them because there's no need, because obviously they're sitting within four separate cabinets. So there's no need to have 8 of them, 12 of them, whatever it may be. Okay, because the entire house has sensors throughout in every zone, floor, area, so I know what is happening at a given point in time. This is more actually at the device level, which is fine. And inside each of the device, anyways, it measures the actual battery temperature, the actual device, so forth. And that's outside of this. Okay, it doesn't need these external I/Os. Over to the left here is two USB ports. Primarily, they're used for flashing the device. It's not actually meant as a means of communication to the actual controller itself. Regardless of what anybody's ever told you, it's more for flashing the device. You can connect through USB, but it's very limited in terms of what you can do there, right? And then down here is, I can barely read it. This is for the console. So that's another, it's like, I don't even know what that type of connection is. It's just this very small, I think it's like 1.2, 2.1 millimeter barrel style connector that goes for there. But I've never seen anybody use it. I've never used it. Whatever. Anyways, like I said, I mentioned, this device gives you the ability to manage, know, communicate, be alerted of a condition for a connected device. So obviously you can control the various outlets here. Okay, some of them allow them to individual or just in banks. You can program them to be either scheduled, react to separate high levels, low levels, anything you need to do. So because during a grid down event, some devices require you to turn on different appliances, either in a specific sequence, order, etc. So you don't have that inrush current. Okay, so depending, obviously, that impacts the actual device in itself. So when the battery packs are really low, having that inrush current fire up all in a row could be detrimental not only to the equipment but to the actual operating system of this. So it'll shut down, it'll do something, wherever it may be, right? So that's why it's important, regular maintenance. So having, more than 25, 30 battery packs, it gets super expensive. So it's something you have to determine your own frequency, regiment, when. Because the battery packs, even on the best case where you have no load ever on them, it's like shoes, it's like underwear. It wears out, okay? Even sitting idle, okay? So the one thing I do have to say, though, the quality of cells that are included in these APC, UPS, and battery packs are top notch, right? APC does not make batteries. They basically sublet them. They come from RBC. They come from Panasonic, Hitachi, whoever, right? So to prove that point, some of these devices, they were brand new, what they call NOS, new old stock. I mean, they were sitting on a shelf, never sold, but they're literally in the box, never charged. And when I got them, they literally lost 1% of their voltage. Okay? One device was literally 10 years old in a freaking box. I was expecting when I got it that UPS would be flat. Hey, and that's it. And that's why you got an awesome deal. But you have to invest another $50, $100, $200 in batteries to bring it back up. Okay? But hey, if this thing costs $2,000 and you got it for $200, so what? You got to put another $400 in battery. You still came out like a bandit, right? You got less than a quarter of the price of the actual unit itself. So that's something to take into consideration. Anyways, back to this thing. So all the units in the house are connected via the NMC. So it allows me to manage the load, to set diagnostics, see the runtime, see the temperature, see the power, energy consumption. It doesn't matter what it is. I'll know, setting different, high level alerts or low level alerts or thresholds, what have you. This device allows me, through the home automation, not only be aware, but set thresholds. And that's the part which is more the fun side. I mean, yeah, geek out. This thing, when it's high, low, whatever it is, or there's some type of something that's out of band. The system I have is called Julie US. So Julie basically is the verbal portion of the home automation, meaning she will tell me anything that's happening. And in this situation, it's about the power or about the network infrastructure that has to do with what regulates and manages the infrastructure. So if something should happen, it communicates to another system, and that system tells me in plain English, saying, hey, there's a fault. There's an over voltage, under voltage. There's too much power being consumed, or the power consumption has actually dropped. So say the load that's on here is supposed to be 100 watts, and automatically say they drop down to 50. Well, there's something wrong. That means a device has died, right? Because, I mean, why would it be 100 watts now it's down to 50 watts? That means whatever was connected has died. Or maybe one of the outlets by accident got turned off, right? Maybe I programmed it incorrectly. Maybe there was some type of scenario where the scheduling was incorrect. Doesn't matter. So that's another measure of failover or backup. So I don't just count on this to operate, which works flawlessly. You should always take it from the perspective that you have something that's validating. Everything's validate, right? So this works awesome. It's bulletproof, but I have other systems that monitor these devices to ensure that they're working top notch, that the information I'm receiving is accurate. So I'll get into that later on. This video is getting long. We're almost breaking 10 minutes. But like I said, I tried to get this the information short and concise. Anyways, check it on the next one.